So before we start today's topic, let's just go back to the topic from yesterday's class and just have a recap. So we started discussing about VLAN and we discussed why VLAN is used, right? And I used a very simple, example of a WhatsApp group, right? So for example, we talk to different people over a WhatsApp group, right? Where we create WhatsApp group based on similar interests. Like let's say there is a, for example, we create a WhatsApp group for for this networking post. There is a WhatsApp separate WhatsApp group, and probably you may be in other WhatsApp group where similar interests are there. Let's say for cricket, or then you have a WhatsApp group for your family members, etc. So based on some common features, we create different WhatsApp groups, and the specialty of that WhatsApp group is that any member who sends a message on a particular WhatsApp group, every other member can see that message, right? This is the basic advantage of a WhatsApp. Similarly, when we are talking from a LAN perspective, okay, local area network. So in this diagram, you can see there are multiple switches connected, sorry, multiple PCs connected to a single switch, right? So it's a small network. Okay, it's a small network which we call it as a LAN, local area network. Right? These PCs are communicating to each other locally in a small area, and hence it's called as a local area network, which we call it as a LAN. Right? So we can create similar groups in a LAN as well, where we as admins we decide which PCs should be in the same group and which PCs should be in the other groups, and that group is called as a VLAN or a virtual LAN, right? And this is what we discussed what a VLAN is about. And then we started discussing that a VLAN can be configured only on the switch interface. Okay, VLAN is configured on the switch interface. That's the second point. VLAN is configured on the switch interface, and VLAN cannot be configured on end devices. When I say end devices, like PC, laptop, printers, servers, not servers, PCs, laptops, because first of all, they do not understand the concept of VLAN. Who understands the concept of VLAN? It is the switch, and we configure this particular VLAN on a switch interface, right? So we started discussing about the VLAN concept, where in this particular, as per this diagram, these two interfaces, interface number one and interface number two, not interface number one and two, interface number one and interface number four are part of VLAN number 10, and interface number two and interface number three are part of VLAN number 20, right? So just like how normal forwarding happens, just like how normal forwarding happens without a VLAN configuration, we discussed how forwarding happens with VLAN configuration, right? So let's say that, let's just quickly have a recap of how the forwarding will happen. So imagine the MAC address table of this switch to be completely empty. Right? Now, PC number 3 wants to send a data to PC number 2. Okay, so this is PC number 3. It is sending a data to PC number 2. Right? So it sends the data to switch number 1. Right? Switch number 1 receives it. First, it will read the source MAC address and it will make an entry. MAC address 3333, and it was received on interface number 3, and this interface is configured for VLAN number 20. Then it looks for the destination MAC address. It is not present in the MAC address table, and as per the switch's functionality, it should forward this data out of all the interfaces. Correct. However, when VLAN is configured, when a particular VLAN is configured, the switch looks for the same VLAN interfaces. So in this diagram, the only other interface which is configured for VLAN 20 is interface number 2. Why is it looking for VLAN 20? Because the incoming interface VLAN is 20. Okay, the forwarding of data or the forwarding of data based on VLAN is completely dependent on the incoming interface VLAN. So here the data is hitting on interface number 3, which is configured for VLAN number 20. That is why switch will look for flooding of this data out of those interfaces which are configured for VLAN number 20. And in this scenario, it is only interface number 2. And luckily, it is received only by PC number 2, and PC number 2's MAC address is 222, right? And hence, the PC accepts this data, right? Now, when PC number 2 responds, the source MAC is going to be 2222, and the destination MAC is going to be 3333, right? PC number 2 responds, right? Switch 1 receives it, and it will make an entry. It will make an entry saying 2222 source MAC address was received on interface number 2, and the interface VLAN is 20. Right? Then it looks for the destination MAC address. Is the destination MAC address present in the MAC address table? Yes, it is present. And to which interface should I send it out? Port number 3. But is the exit interface or is the outgoing interface VLAN same as the incoming interface? Yes, that is also correct. And hence, this switch will forward the data to PC number 3. And hence,
So
PC3.
So is there any possibility that this, like when the first entry came 3333, this one got entered 3, and second time the entry came for 2222 for second port and 20. By any chance, if this first row gets changed from VLAN 20 to 30, and by the time the reply comes, so any way it can change, like, or it will, once it is entered, it will remain same.
No, every time a new data is received, this will be updated. Every time, let's say you said instead of 20, now by the time PC2 responds, this became 30.
This became
VLAN
31st
30.
row. No, not
Yeah.
that one. This one, this port 3, this one.
Okay.
By the time response come, the port 3, this has changed to 30. Now what will happen? So, like by some reason it changed.
30. Okay. Now, for some reason, it changed, right? Now, what will happen? For some reason, it changed. Obviously, this entry is present. This entry is present in the MAC address table. Okay. But what would happen is, since obviously for some reason it changed, now how will it change? Until and unless we configure it,
Manually.
we configure as an administrator configures it to be 20 or 30, okay, it cannot change. First thing first, okay, you need to configure or you need to make that change. Then only this interface will change to 30. The switch cannot automatically change it to some other VLAN.
Because only manual intervention is required to change.
Only a manual intervention is required. Okay, only manual intervention is required. And now let's assume that the change, the manual intervention that is happened is so quick, like, it is even faster than getting a reply like this. Okay, obviously it's too quick. Okay, first of all, it is not possible manually to change from 20 to 30 within a fraction of seconds.
Within millisecond, nanosecond, something.
Yeah, it is faster than that. Obviously, it is like manually, it is not possible. And let us hypothetically assume it is possible. Let us hypothetically assume it is possible. This becomes 30 with manual intervention. Now, what will happen is in switch show VLAN tab, when we do a show VLAN tab, it will say that interface number 3 is configured for port number 30. Okay. Now, what will happen in the MAC address table? There is a conflict now.
Yeah, it's 20 and here it is 30.
There is a conflict now. But over here, the switch is not going to believe the MAC address table. It will believe the show VLAN table because that's the ultimate truth for it.
Okay, so if it finds a MAC address table is different, then it will check the show VLAN. This one, it will check twice.
Okay, let me think once again your question. Okay, hypothetically, okay, fine. I know the answer. It's a good question. Okay, it's a good. You can think of a tricky interview question. Okay. So now, port number 3 has changed its interface to 30. Okay. Now, But in the MAC address table, this interface is still configured for VLAN number 20. Okay, it will still send the data because as per the MAC address table, the incoming interface VLAN and the outgoing interface VLAN as per the MAC address table is 20, and hence the data will be sent out. Now, when will this MAC address table be updated? It will be updated only when PC number 3 responds again.
Again, it responds something. Like again, it tries to
Now,
ping or do something.
when PC3 sends a data, as if you remember our discussion of how switch populates its MAC address table, it is
MAC
only
table.
when it receives a data.
Source. Yeah, source. Based on
Yeah,
source.
based on the source. Okay, so when not based on the source, it populates the data when it
Receiving.
receives.
Receives.
It
Yeah, right.
receives in a data.
Receive.
So over
Right.
here, it is not receiving; it is actually sending the data. When it is sending the data, it is actually looking at the MAC address table.
Okay.
It is looking at the MAC address table. But as per the MAC address table, the VLAN is still 20, and it will send it. Now, next, when it receives the data, that time it will check the show VLAN table where it will say port number 3 is belongs to VLAN number 30, and then it will change this VLAN to 30.
MAC table. Okay.
Got my point?
Okay. Got it.
Yeah, it's a nice question. I liked it. I've never thought, not thought, no one has ever asked this question, but it's a good tricky question. All right. So now you know the concept of how data is being transferred through VLANs. We did the practical for it as well in the last class. Now, with a single switch, it is okay. What if there are multiple switches, or if there are two switches? PC1, PC2, and this is switch number 2, PC3, and PC4. Okay. This is configured for VLAN number 10. This is configured for VLAN number 20. This is configured for VLAN number 10, and this is configured for VLAN number 20. Okay. Now, in this case, and if you remember in the last class, we were talking about access ports, okay, or access VLANs or access mode. Okay. With when we are talking about access mode, these two interfaces are again access mode VLAN 10 configured. Again, on these two switches also, there access mode VLAN 10 configured. Access mode means only one VLAN is allowed, and that VLAN is whatever VLAN you configure it. That is what access VLAN means. Access mode meaning just one VLAN. All right. Now, okay. Now let's say PC1 and PC number 3, they want to communicate. PC1 and PC3, they want to communicate. Now, as an admin, we know that these two PCs are connected to interface 10. Sorry, interface VLAN 10. So I configure VLAN 10 over here. I configure VLAN 10 over here. Now, in this scenario, PC1 and PC3 will be able to communicate. However, if PC2 and PC4, they want to communicate, it will not be possible. Why? Because when PC sends a data, switch will make an entry for it. It will automatically know that this interface is for VLAN number 20. And the exit interface, let's assume that this switch knows that this PC's VLAN or this PC is connected on the other switch. However, it will not be able to send because this interface is for VLAN number 20. This interface is for VLAN number 10. The switch already knows it. It's like on the same phone. Let's say you are the user of the phone. You already know that this is WhatsApp group A and this is WhatsApp group B. So obviously the messages that is sent in WhatsApp B will not be forwarded to WhatsApp A, right? You already know it because you are the admin. You can clearly see this is a different group and this is a different group. So obviously the messages, let's say B is an official group, okay, and this is a family group, right? So obviously you're not going to send family messages into official group and vice versa. Similarly, the switch knows that the two VLANs are different, and hence it is not even going to forward the data out of this port, VLAN interface 10 port, right? So there is a problem where PC2 and PC4 cannot. So the other solution is I will make that change to VLAN 20. Now what will happen? PC2 and PC4 can communicate. Okay. However, PC1 and PC3 will not be able to communicate because again, the two interfaces have a different VLANs. So this is a problem. Okay, this is a problem where every time I have to make PC1 and 3 communicate, I'll have to change the VLANs to 10 over on the switches on both sides. When I want PC2 and PC4 to communicate, I will have to make the VLANs as VLAN 20 between the switches. So it's a very tedious task for me. Okay, it's a very tedious task for me to every time go and change the VLANs.
And that too, if like all the 24 ports are connected to different VLANs, then it will become more difficult to both sides. Like
Correct.
24 PCs this side,
Yeah, yeah,
24 PCs that side.
The other solution is, yeah, you are correct. The other solution is you can configure here VLAN 10, and this has VLAN 20, and this has VLAN 20. This is possible, but this is not a feasible method because let's say the two switches only have 8 ports, for example. They have only 8 ports, and let's say there are 20 VLANs that are configured on the switch.
Okay.
You can configure, so you can connect 8 ports on the switches together. What about the rest of the 12 ports or the rest of the 12 VLANs? For 8 ports, you can have 8 VLANs. What about the rest of the 12 ports or 12 VLANs? Okay, so that's a loss. And that is why connecting multiple interfaces and configuring different VLANs on these two physically over the interfaces is not a feasible method. Is not at all a feasible method. So what we basically do is we try to configure multiple VLANs on a single port itself. So as per this topology, I can configure VLAN 10 on this interface as well as VLAN 20. Here also I can configure VLAN 10 and I can configure VLAN 20 as well. So that both these PCs, PC1 and PC3 and PC4 and PC2, they can communicate. Okay, and this kind of this kind of feature where I can configure multiple VLANs on a single interface is called as a trunk port. It is called as a trunk port or a trunk mode. Okay, I just showed you the access mode where I can only configure one VLAN. I can configure only one VLAN, but with trunk mode or a trunk port, I can configure multiple VLANs on the same switch, on the same interface. Okay, on the same interface, I can configure multiple VLANs. Right. So let us now see how will this work with multiple VLANs. So switch number 1. This is PC1 with VLAN number 10. This is PC2 with VLAN number 20. PC3 VLAN 10. PC4 VLAN 20. Now, as I said, I'm going to create a trunk port over here with VLAN 10 and VLAN 20 configured. How to configure a trunk port, I'll show you probably later in this course or in this class. Right? And I configure here also 10 and 20. Let me mark these interfaces as interface number 1, interface number 2, and interface number 3. Here also, this is interface number 1, this is interface number 2, and this is interface number 3. The greens are interfaces. Okay. Now let's say PC1 has a MAC address 1111. This is 2222. This is 4444, and this is 3333. Okay. Now PC1 tries to ping PC number 3. Okay. Source MAC is going to be 1111. Destination MAC is going to be 3333. Okay. So switch one's MAC address table will contain a MAC column, a port column, and a VLAN column. This is switch number one. Similarly, for switch number two, you will have a MAC column, port column, and a VLAN column. Right. Now, PC1 sends the data. Okay. Switch number one makes an entry. It reads the source MAC address 1111, port number one, and it was received on an interface VLAN 10. Okay. Next, it will read the destination MAC. Is the destination MAC present in the MAC address table? No, it is not present in the MAC address table. So it is supposed to flood it out of all the interfaces. So it will see which are the other interfaces where VLAN 10 is configured. Okay, so it looks at the show VLAN table. It looks at the show VLAN table, and it will see that, not show VLAN, show trunk interfaces. We'll talk about that command later. But it checks which are the other interfaces where VLAN 10 is configured. So it sees that this is the other interface, or interface number 3 is the other interface where VLAN 10 is configured. Right. So over here, it will flood this data out of this interface. Okay. Switch 2 will receive it. When switch 2 receives it, it will read the source MAC address, will make an entry of 1111. It was received on interface number 3, and it was received for VLAN number 10. It was received for VLAN number 10. Then again, it will read for the destination MAC. It does not see the destination MAC in the MAC address table, and hence it is supposed to flood it. But it will flood it only on the interface where VLAN 10 is configured, and this is the only interface where VLAN 10 is configured, and hence PC3 will receive it. Okay, is this flow clear?
Yes, it's clear.
Now, when PC3 responds, let me change this here. Source MAC is going to be 3333 and destination MAC 1111. Right? PC3 responds. Switch 2 receives it. It makes an entry. 3333 was received on interface number 1, and it was received on interface where VLAN 10 is configured. So it makes an entry. Okay. Then it looks for the destination MAC. Yes, the destination MAC is present in the MAC address table. It is supposed to be sent out of interface number 3, and is the incoming interface and the exit interface part of the same VLAN? Yes, they are part of the same VLAN, and hence it will forward it out of interface number 3. Switch 3 receives it. It will make an entry. 3333 was received on port number 3, and it was received for VLAN number 10. Then it checks the destination MAC. The destination MAC is present in the MAC address table. It is supposed to be forwarded out of port number 1, and the incoming interface VLAN and the exit interface VLAN are part of the same VLAN, and hence the data will be forwarded to PC number 1. Okay, is the flow clear?
Yes, right, it's clear.
Now, one thing which you may have missed, or probably it would have come to your mind and wouldn't have asked, is that when the switch number 1, when the switch number 1 is forwarding the data to switch number 2, how does the switch number 2 identifies that it has come for VLAN number 10? Okay, so this was the initial entry, right? This was the initial entry where first, okay, first flow where switch 2 receives it. Switch 2 will make an entry that MAC address of source MAC of 1111 is received on interface number 3, and I just simply wrote it is received for VLAN number 10. How does the switch know that it is for VLAN number
10? Here two things are there, right? 10 and 20 both are there.
Correct.
So,
Here both are there. How does the switch identify? Is it for VLAN 10 or is it for VLAN 20? The data that I have received, is it for VLAN 10 or is it for VLAN 20?
The sending part is fine because it will see that that exists or not, it will send. But the receive
Correct.
part, yeah, receive part, it has to identify somehow.
Yes. How does it identify?
Otherwise, it would have sent to PC4 also.
Correct. That's the question. How does it identify that it is VLAN 10?
There must be some
It is,
internal mechanism.
yeah, that's absolutely right. So that is the work of a trunk port. As I said, these two interfaces, we are configuring them as a trunk port. Correct? We are configuring them as a trunk port. When I configure these two interfaces as trunk port, whatever VLAN that is sent out, whatever data is sent out, it will be tagged. It will be tagged with a VLAN ID. It will be tagged with a VLAN ID. And with what VLAN ID will it be tagged? Because the incoming interface was for VLAN number 10, when it is sending the data out of this interface, it will tag it with VLAN number 10. And hence, when switch number 2 receives this data, it knows that this data was received for MAC address 1111 on port number 3 and for VLAN number 10. Then it looks for the destination MAC, which is not present in the MAC address table, and it floods it out of only those ports where the interface VLAN is configured for 10. That is only this interface.
Okay, got it now.
Okay, so VLAN ID or VLAN tagging is very important for a trunk port. Let me repeat that again. Okay, so here, let me repeat this whole process once again with VLAN tagging. So PC1 sends the data, switch number 1 reads the data with source MAC as 1111. It was received on interface number 1 with is configured for VLAN number 10. Okay. Now it looks for the destination MAC address, which is not present in the MAC address table. Now it looks for the other interfaces where VLAN 10 is configured. That is only this interface, interface number 3. So it will send this data out of this interface, but it will also tag it with a VLAN 10. The data that it sends, it will tag it with VLAN number 10. Now, switch number 2 will receive it. It will see I have received a data with a source MAC of 1111 on interface number 3, and it is tagged with a VLAN of 10. Then it looks for the destination MAC address, which is not present in the MAC address table. So it sees that which are the other interfaces that are configured for VLAN number 10, and that is only interface number 1. And hence, the data is forwarded out of this interface. Okay, clear? Is this flow clear?
Yes, it's clear.
Now the return traffic. When switch 3 responds, sorry, PC3 responds. Source MAC is 33331111 is the destination MAC. Right. PC number 3 responds. So it makes an entry of PC's MAC address 3333 received on interface number 1, which is configured for VLAN number 10, which is the other. Now it looks for the destination MAC. Is the destination MAC present in the MAC address table? Yes. Which interface should it send it out of? VLAN number, sorry, port number 3 or interface number 3. Is the incoming interface and the outgoing interface part of the same VLAN? Yes, they are part of the same VLAN. So it will forward it, but it will also tag it with VLAN number 10. It will also forward it or tag it with VLAN number 10. Now, switch number 1 will receive it. It sees that it has received data of with a source MAC of 3333 on interface number 3 with a VLAN tagging of 10. Then it looks for the destination MAC address. Yes, it is present in the MAC address table. It should forward it out of interface number 1. And is the incoming interface VLAN and the outgoing interface VLAN, are they same? Yes, they are same, and hence the data is forwarded to PC number 1. Clear?
Yeah, the same process is in both ways is followed, right?
Yes, both. So when a switch is configured with a trunk interface, when a switch is configured with a trunk interface like these two interfaces are configured as trunk mode. Trunk mode where multiple VLANs can be configured on the same interface.
So
So on a
one
trunk
trunk is
mode,
sufficient. So one trunk is sufficient for like as many number of things I can add, or we need multiple trunk.
you can add 4096 VLANs on the same interface.
And trunk this connection also we can do multiple trunks we can make. Then is there any use, or it's only one trunk we can make and everything we can use it through that?
See
Like suppose
again, yeah,
40
yeah.
different 40 different VLANs. So suppose 100 different VLANs there. Do we pass it through this same trunk, or we again create some more connections
Okay,
there and then?
yeah. Again, a good question. So what we can do is we can, let's say the capacity of this link, the capacity of this link gets overloaded. It is not able to handle the data that is going between the two switches. So you can segregate the VLAN. Let's say you have 100 VLANs. As you said, you have 100 VLANs. Okay. So what you can do is from 1 to 10, you can have one interface, one physical interface. Then from 11 to 20, you can have other physical interface and configure trunk port. Okay. Let's say link number one, link number one with VLANs 1 to 10, configure as trunk mode. Link number two, configure as trunk mode with different set of VLANs. Link number three, configure as trunk port with different set of VLANs. You can configure it like that.
Okay.
But when the data is flowing, as I said, okay, okay, when you configure these different links for different trunks, obviously you will go on that interface configuration and then configure it for the trunk. So let's get into the practical directly. Okay, I'll show you how to configure trunk, and then we can understand how trunk is working. Which one? PC1, PC2, and PC. Let me give an IP address 10.0.0.1, PC number 2, 10.0.0.2, PC number 3, 10.0.0.3, and PC number 4, 10.0.0.4. Now, we quickly check the clear. Where now what I'm going to do, as I said, I will configure the these switch interfaces as we had discussed in the diagram earlier. Okay, so these two interfaces on VLAN, this interface on VLAN number 10, this interface on VLAN number 20, and this interface as whatever this interface number is there on the Cisco packet tracer as a trunk. All right. So on switch number one, okay, to to configure for a switch, we will get inside its configuration mode. So configuration terminal, right? then interface fast Ethernet 0/1. In short, you can write fast Ethernet as F0/1. Right? Then switch port mode access, because we are going to configure only one VLAN on this particular interface. That is why access mode. Switch port access VLAN 10. Right? And this is another way of creating a VLAN. Okay. So you can simply create VLAN by typing like this, exit. Okay. VLAN 20 like this. VLAN is created. That's all. So if you do a show VLAN, you will see both the VLANs configured, VLAN 10 and VLAN 20. But with the earlier step or the first step that I did, switch port access VLAN 10. Here I'm avoiding this extra step of first creating VLAN 20 and then adding VLAN 20 to a particular interface. I'm completely avoiding that step. And I directly went into the interface configuration mode and configured a VLAN 10 to it. So it says access VLAN does not exist or access VLAN 10 does not exist, and hence it is creating. Very simple. Okay, so you can
But you executed
avoid.
the two times, right? The command for the first one. You have two
Yeah,
times you have written switch port mode access, again switch port access VLAN 10.
yeah.
So two times we need to give that.
Again, it is not necessary. Okay, it is not necessary to give this two commands twice. You can simply write switch port access VLAN 10 and it will work the same. Okay, but
Either that way or we can use directly the VLAN 10. So anyways, like one way.
mm,
The
yeah,
second one
okay,
is second option
yeah,
I
yeah,
told, right?
okay. When I'll configure it on switch number 2, I'll tell you.
Okay.
Okay, what you're saying, I got your point. Okay, so over here, as I said, this one I'm writing switch port mode just to make sure that this particular interface is on the access mode. Okay, and then what I'm saying is this switch port is an access mode with a VLAN of 10. Because I did not create VLAN 10 separately like this, it said access VLAN is not access VLAN does not exist, and hence it is creating. Now, in the second example with VLAN 20, I explicitly configured VLAN 20. Now, when I configure this particular part, when I configure this thing for interface 0/2, it will not throw me this particular warning. Okay, so let's do that. Configuration terminal, interface fast Ethernet 0/2. Okay, switch port mode access. Okay, switch port access VLAN 20. So over here, you can clearly see it does not throw me that warning that VLAN 20 does not exist, creating VLAN 20. Okay, why? Because I explicitly created VLAN 20 over here. That's the only difference. I can directly go with this step by avoiding creating a VLAN 20. Okay, I can directly go to this interface configuration saying switch port access VLAN 10. It will automatically create a VLAN 10 for me. And it will also say that this interface is part of VLAN 10. Right, whatever interface that you are configured for, it says for VLAN 10 or 20 or whatever. So let's do a show VLAN and you will see fast Ethernet 0/2 is configured for VLAN 20 and fast Ethernet 0/1 is configured for VLAN number 10. Right. Now, on fast Ethernet 0/3, which is between switch 1 and switch 2, configuration terminal, interface, fast Ethernet 0/3. Okay, so I'm typing INT as or interface as short form. Interface as short form for INT. Okay, let me show you INT. And if I press tab, which is an auto completion button, tab button on Windows, it will auto complete it as interface. Okay, so to save time, I'm just writing INT and fast Ethernet 0/2. If I press tab after F, it will complete it as fast Ethernet only. And I can type 0/. So instead of typing such a long command prompt, I'm just typing in short interface fast Ethernet 0/2 and it will produce me the same result. All right, interface fast Ethernet 0/3. Then I will say switch port mode. Previously, these two interfaces, 0/1 and 0/2, were only access mode, where I am configuring only one VLAN. But this is a trunk mode or a trunk port where I want multiple VLANs to be configured on that screen. So I will say switch port mode trunk, switch port mode trunk. Okay, then which VLANs should I allow over this trunk mode? Switch port trunk allowed VLAN 10, 20. So on this particular interface or on this particular interface, I have allowed only VLAN 10 and 20 to pass. Any other VLANs. Okay, again, this please listen to this very carefully. Any other VLAN. We know that the VLANs can be from 1 to 4096. In that range, from 1 to 4096, I am allowing only two VLANs to pass through this particular trunk with this command. Switch port trunk allowed VLAN 10, 20. Okay. Now to check the VLANs on fast Ethernet 0/3, if you do a show VLAN, it is not going to show you any result. See over here. Here you have 0/1 and 0/2, and from 0/4 to gig 0/2, you have all the other interfaces. But 0/3 is missing, which is configured for a trunk. So with show VLAN command, you cannot see trunk interfaces or a trunk mode interface. You cannot see with a show VLAN command. But an access mode VLAN interface or an access mode interface, you can see with a show VLAN command. Okay, show VLAN, we configured it as switch port access VLAN 10, switch port access VLAN 20. Right. But for VLAN, but for 0/3, we configured it as switch port mode trunk. And you can see trunk interface is not present. So to check trunk interface, we will type show interfaces trunk. Show interfaces trunk, and we can see 0/3 interface. Okay, 0/3 interface. Leave this particular row as of now. We'll talk about this row later. Okay, you can see interface trunk. It is 0/3. Which VLAN is allowed? VLAN 10 and 20. Again, leave these two rows for now. So the first row and the last two rows, leave them for now. We'll only consider it on this row. VLANs allowed on this trunk. That is on this interface, 10 and 20 are the only VLANs that are allowed on this particular interface. Okay, a similar configuration, we will do it on switch number 2. Okay, now let's try to cut down our command lines on switch number 2. How can I cut down? Instead of typing VLAN 10, VLAN 20, switch port mode access, switch port mode access, then switch mode access VLAN 10, 20. What I can do? I'm showing you that now. Configuration terminal. I will go to interface number 0/2. Interface fast Ethernet 0/2. I'm supposed to configure this interface for VLAN number 10. Right? Previously, what I used to do, switch port mode access. This is what I used to. Now, instead of this, I can simply write switch port access VLAN 10. So over here, with just one single line of command, I'm actually typing two commands together. One is VLAN creation, the other is switch port mode access command, or this command, switch port mode access command. I'm completely avoiding this command and VLAN 10 creation command. In just a single line of command, I'm doing both, or I'm executing both these commands together. Okay, so switch port access VLAN 10. Now let's check the show VLAN command, show VLAN, and we can see VLAN 10 is created and it is part of 0/2. And we just discussed this shows access ports. When you do a show VLAN show VLAN, it shows you the access port fast Ethernet 0/2, and it is configured for VLAN number 10. So I avoided the two steps. Which are those two steps? Like this, VLAN 20. VLAN 20 is created. Okay, show VLAN. VLAN 20 here is created, but it is not configured to, or it is not attached to any interface, right? And then if I want to attach it, I will say interface fast Ethernet. Which interface is it? 0/3. Okay. Fast Ethernet 0/3. Okay. So switch port mode access, then switch port access VLAN 20. These multiple steps of configuring a VLAN, then attaching that VLAN to a interface, I have completely cut it down or shorten it to one single command. That is this command, switch port access VLAN command. So with this, I'm creating a VLAN. I'm also making sure that this interface becomes an access node. Got it?
Yeah, got it.
Now, and let's do a show VLAN. Show VLAN. So we'll see this that 0/3 has become a part of VLAN 20. Now, trunk mode. Fast Ethernet 0/1. Interface fast Ethernet 0/1. Switch port mode trunk. Switch port trunk allowed. Now, for trunking, yes, you need to specifically mention mode trunk. You cannot skip this particular configuration, unlike access mode, where you can simply change, or you can simply skip that particular command name, switch port mode access. Here, you cannot skip this command. You have to explicitly mention that this interface is in the trunk mode with switch port mode trunk command. Okay. Switch port trunk allowed VLAN 10, 20. Now let's check if interface 0/1 is configured for trunk interfaces. Show interfaces trunk. So you can see fast Ethernet 0/1 is configured for VLAN 10 and VLAN 24. All right. Now let's do our practical. Check show MAC address table, clear MAC address table. Here also clear MAC address table. Clear MAC address. Okay. Let's go to the simulation mode. Please remember. Okay. Let me highlight. So this is VLAN number 10. This is VLAN number 10. This is 20. This is 20. These two interfaces are both VLAN 10 and 20. Okay. Now from PC number 1, I'll try to ping PC number 3. Ping 10.0.0.3. Okay. Okay. And ARP is created. We'll talk about ARP later. Okay. But the working remains the same. Okay. And ARP. ARP. We'll talk about the full form and how ARP works. What is basically an ARP? We'll talk about that in length probably later. But for now, just understand it's a broadcast packet. It is a broadcast packet because you can see the destination address is FFFF, all FFFF. And if you remember from our earlier classes, I had mentioned three types of layer 2 traffic. One was a unicast, the other was a broadcast, and then the third was a unknown unicast.
Yeah.
Right. So this one is a broadcast. ARP is a broadcast. Okay, where the MAC address is specifically FFFF. You can see all the digits of the MAC address is FFFF, which automatically the switch understand it's a broadcast. Okay. Now let's see how is the switch basically processing this. Okay. So the source MAC is 6118. It ends with 6118, and this is an ARP. So the destination MAC is FFF. All right. Now the PC forwards the data. It is received by the switch. Switch makes an entry. So show MAC address table. Oh, I need to let me
Here
clear
that
this.
time, so again it came.
Yeah. Probably. I'm not sure why. Let me quickly clear the map. Here. Hmm, no, hope I don't see.
So it's automatically coming directly here.
No. It is the MAC address E2010/3. Yeah, it is the. This is the MAC address of switch number 2, not of the PCs.
Okay.
So I'm okay. I'm okay for that. I mean, it should not have the MAC addresses of other
Other PCs.
PCs. So this is now completely empty. So now let's again ping. Okay. Now, obviously, the destination MAC would change. The destination MAC is E6B4. Okay. E6B4. Okay. This is the data right now. Okay. The source MAC and the destination MAC. So the switch will, not the switch, the PC will forward it. Okay. The switch will receive it. When the switch receives it, what is it going to do? It is going to make an entry, correct? The source MAC as 6118, right? It was received on 0/1 with where the interface VLAN was interface or the VLAN number 10, correct? Let's check that. Show MAC address table, and we can clearly see 6118 for 0/1 and interface VLAN number 10, right? Then it looks for this MAC address E6B4. We can see E6B4 is not present in the MAC address table. Because E6B4 is not present in the MAC address table, it is supposed to flood this data, right? It is supposed to flood this data, but it will flood this data only to those interfaces where VLAN 10 is configured. And as per the show interfaces trunk command, 0/3 is also configured for VLAN number 10. It is configured for 10 and 20 both. Okay. So now what the switch is going to do? Switch is going to forward this data to switch number 2. It did not forward it here because this interface is configured only for VLAN 20. Why? Because this was an access mode. This was an access mode, and only 20 is configured. Switch did not forward it out of that interface. But the trunk interface is configured for VLAN 10 and 24. That is why it was able to forward. And let's go back to the data and open this packet and see the difference of the data over here. So this is the incoming packet. This side is the incoming packet, meaning this way, right? So over here, you can clearly see the source MAC, the destination MAC, and over here, there is no VLAN ID mentioned. And as I said, devices, end devices like PCs, laptop, printers, they do not understand VLANs. That is why there is no VLAN tagging over here. And as I showed you in the note, I mentioned VLAN is configured on the switch interface, right? Yeah, VLAN is configured on the switch interface. Right? So it is configured on the switch interface, and hence who will tag or who will tag it with the VLAN? It is the switch who is going to tag it, right? Now check the outbound detail. Let's check the outbound detail. In the outbound detail, now we'll see a difference. You can clearly see a difference. There are few more details or few more headers or fields added. Okay, and we are interested in this particular header, that is TCI. The full form is Tag Control Identifier. Tag Control Identifier, and it clearly mentions A. A. A is a hexadecimal value. If you convert it into a binary form, you will get it as 1010. And if you convert it into a decimal form, the value is 10. So it is written in hexadecimal format. The no, the decimal value is 10 for it, right? So this particular data now is tagged with a VLAN ID of 10, because it's a trunk interface, and on the trunk interface we just discussed that the switch will add a VLAN tag to it. So a VLAN 10 tag is added. The switch will forward the data. Switch 2 will receive it. Okay, let's open this. When switch 2 receives it, it now is reading a lot more data. It is reading the destination MAC address. It is reading the source MAC address. It is also reading the VLAN ID. So it makes an entry. The switch makes an entry. So it makes an entry saying a MAC address with 6118 is received on interface number. What was the interface number? 0/1. 0/1 with a VLAN tag of 10. How is switch number 2 understanding that it is VLAN number 10? Because in the receiving packet, the receiving packet has a VLAN tag of 10. Has a VLAN tag of 10. That is why the switch knows that it is for VLAN number 10. Okay. Now let's do a show MAC address table. Show MAC address table, and we'll see the same thing. You can see 6118 on 0/1 for VLAN number 10. Okay. The next, it looks for E6B4. E6B4 is not present in the MAC address table. Correct? E6B4 is not present in the MAC address table, so naturally it is supposed to flood it out of all the interfaces. But it will flood it out only out of this interface, because as per the trunk command, this is the only sorry, as per the show VLAN command, this is the only other interface which is configured for VLAN number 10, and hence it will forward it out of this interface, and PC3 will receive. And fortunately, PC3's MAC address is E6B4, and hence PC3 accepts it. Is this flow clear?
Yes, it's clear.
Right. Now let's go for the return traffic. When the return traffic starts, this is the destination MAC and this is the source MAC. Okay, so let's open PC3's data. We can see destination MAC is E6B4. Oh, sorry, out of that. Destination MAC is 6118. So destination MAC is 6118, and E6B4 is the source MAC. E6B4 is the source MAC. And you can clearly see that the inbound packet, or let me go back. The switch here When it is sending the data towards PC, this is the input detail or the inbound data with a VLAN tag of 10, which is received from switch number 1. But when it is sending it to the PC, here, look at the outbound side, it removes the VLAN tag. The switch removes the VLAN tag. Why? As I said, the end devices, PCs, laptops, they do not understand VLAN. That is why it has completely removed this VLAN tag. It has removed this VLAN tag. And why did it remove? The another reason is that because this is an access port. On an access port, again, on an access port, tagging is not done. Very simple.
But
Tagging will not be present on an access port.
this is
Tagging
going,
is tagging
this is
is
going
always
towards
trunk.
PC or coming back?
No,
This one is,
this is going to this.
oh, this is going now towards this. Okay.
Yeah.
Okay, now it is removing it and then sending to the PC. And while
Yeah.
it came from this
Why is
switch
it
to this
removing?
switch,
Again, why is it removing? Because this interface is configured as an access mode.
access. Okay, it won't understand that thing.
Yeah, on an access mode, there is no tagging done. No matter what VLAN you configure. VLAN 10, 20, 30, 40, 100, no matter what VLAN you configure, on an access mode, VLAN is not tagged. It is not because a PC is present there. It's not because a PC is present there, it is removing. No, it is because this is an access mode. On an access mode, tagging is not done. Tagging is always done on a trunk port, trunk mode or a trunk. Clear?
Okay, yeah.
So people sometimes think that because PC3 does not understand VLAN and PC is connected to the switch, it removes it. No, the switch is completely unaware of what device is connected to. It can be a switch also. It can be a router also. It can be a server also. It does not know what device is it connected to. It only knows that this interface is an access mode, and on this access mode, I will not tag it with a VLAN. That's all it knows. All right. So when I'm sending a data, I will not tag it. When I'm receiving a data, it should not have any tag. Simple, simple fun. When I'm sending the data out of an access mode, I will not tag it with a VLAN. And when I'm receiving a data, that data should also not have a tag. It should not have a tag. Simple.
When it is receiving, like in that
When it
access,
is receiving, yeah,
in that access.
on that access, it should not have a tag.
Okay. And one more thing, now if that the point is connected to the PC, if I change that from access to trunk, what will happen? Is it allowed or like now,
Wait,
suppose,
sorry, yeah, tell me.
okay, suppose this F01 is there, this set is connected to the PC. So it was
Hmm.
access now. Okay. So now, can I change it to trunk? What will happen? Is it allowed? If it is
This one, this port.
this port, yes.
Yeah, you can change it to trunk. What there is no the switch will allow you.
Switch will allow. Okay.
The switch will allow you. There is no worries. The switch will allow you. Okay. And when the switch is forwarding the data, it will tag it with some VLAN, whatever VLAN that the receiving interface is configured. Okay. On the receiving interface, whatever VLAN it sees, it will tag it with that particular VLAN on the exit interface. However, when the PC receives it, it is not going to understand that.
Not going to process. Okay, got it.
It will not even read that VLAN. It will not read the VLAN. Simple. Because it does not understand. Yeah.
Okay, clear.
Yeah. So on access port, no tagging is done. Only on trunk port, a tagging is done. Simple. Okay. Now let's go back to our discussion. The switch will not tag it with any VLAN because the outgoing interface is an access port. And as I said, on an access port, no VLAN tagging will be done. So it forwards to the PC. Okay. Now the destination MAC is 6118, source MAC is P6B4. The PC sends the data to the switch. Now switch has to make an entry, right? So it will receive it will say E6B4 was received on, if I'm not wrong, 0/2. Yeah, 0/2. It was received on 0/2, which is configured for VLAN number 10. Access VLAN 10. Let's see, show MAC address table, and we can see E6B4, 0/2, and VLAN number 10. Right. Then it checks the destination MAC. Is the destination MAC present in the MAC address table? Yes. Out of which interface should I forward it? 0/2. And is the incoming interface and the outgoing interface, are they part of the same VLAN? Yes, they are also part of the same VLAN. So this criteria matches. The incoming interface and the outgoing interface are part of the same VLAN. That criteria matches, and hence the switch will forward it out of 0/1 to switch number 1. Now switch number 1 will receive it. It will make an entry, right? It will say source MAC as E6B4 is received on 0/3. Okay. Now here on the, again, here this incoming data is tagged with a VLAN 10 because it's a trunk interface. So when switch 2 is forwarding, it will tag it with a VLAN 10. Okay, because it's a trunk interface, it will tag it with a VLAN 10. So the incoming data has a VLAN tagging of 10. Has a VLAN tagging of 10. So these data is updated by switch number 1. So E6B4 0/3 VLAN number 10. Now the destination MAC 6118. Is 6118 present in the MAC address table? Yes. Out of which interface should it send out? Out of which interface should it send? 0/1. Is the incoming interface and the outgoing interface part of the same VLAN? Yes, they are part of the same VLAN, and hence switch will forward it to PC number 1. That is how the two PCs are able to communicate.
So one more thing in that uh, the MAC table, there were entries for VLAN 10 three times. How it is three times, like a second
Yeah.
row, third row, and fourth row.
So
So VLAN is
6118,
one is for F0
6,
by 3, one is for F0 by 1, and other
see,
one
this one is extra, this one is extra. Okay. E6B4, this is PC1. Sorry, this is PC number 3.
3.
This is PC number 3's MAC address. This is PC number 1's MAC address. Okay. And this one, E201, is switch's MAC address. Switch 2's MAC address.
Okay, okay. Switch
This is
2,
switch
that
2's
also
MAC.
is, that also is 10, right?
Yeah. No. And if you notice, it says both VLAN 10 and VLAN 20. It
VLAN
has two
20.
entries because 03
Okay.
is configured for a trunk interface. That is why it is saying that this particular MAC address belongs to both the VLANs, 10 and 20.
So that, okay, got it. That's the same MAC address, right? Yes.
Yeah, they're the same MAC address.
Okay, got it.
Okay. You have another with VLAN number 1, okay, which is the default VLAN. So default VLAN and the two extra VLANs that we configured all have switch 2's MAC address. Okay. Do not worry about this particular VLAN as of now. Okay. I'll explain that probably Tuesday. Monday is holiday. I'll explain
Oh,
that on Tuesday.
Tuesday. Okay, sure.
Now, what will happen if PC1 tries to ping PC number 2? What happens if PC1 tries to ping PC number 2? Okay, so let's see that very quickly. Ping 10.0.0.4. Okay. Here, the data is sent to switch number 1. Switch number 1 obviously is going to make an entry. It already has an entry for PC number 1's MAC address. That is 6118. 6118 0/1 interface number 10. Okay. Then it checks the destination. The destination MAC over here, as I said, it's an R, okay, which is a broadcast packet. However, this broadcast packet will be sent out of only those interfaces that are part of VLAN number 10. This is VLAN 20, so it's not going to send out, but this is part of VLAN 10 and 20 both, correct? So the switch forwards this broadcast out of that interface and switch 2 receives it. Okay. When switch 2 receives it, it will see the VLAN tag, that is VLAN number 10. This broadcast is tagged with a VLAN 10. So now switch 2 will look for all the interfaces that are part of VLAN number 10. And since this is the incoming interface, the switch is not going to forward it back out of this interface. This is the only other interface that is part of VLAN number 10. And since this is a broadcast packet, this is a broadcast packet. All F is a broadcast. Switch will forward it to PC number 3, but PC number 3 will reject it. And see, it rejects it because it's PC4's, whatever PC4's MAC addresses, that is not PC number 3's MAC. And hence that packet is rejected. Okay, so what is happening? This is VLAN 20. This is VLAN 20. This is VLAN number 10. And hence, two different VLAN devices are unable to communicate with each other. Got it?
Got it. Because the IP was different, so that's why that rejected. It
MAC,
was
yeah,
for
the MAC address is different. MAC address is
it
different as well
pinged
as
that.
yeah, MAC address and IP both are different. Correct. You're right. IP is different. This PC is IP address is 10.0.0.3 and
And that one is
VPIN for
10.04 last
4.
one.
That is why it rejected. Okay. So with this, what we are saying is that on access port or access mode, only one VLAN can be configured, and there will be no tag on it, with no tag. But on a trunk mode, you can have multiple VLANs, multi VLANs, and tagging will be present for the respective VLAN. Again, the tagging is based on the incoming interface VLAN. The interface where the data is received, the switch checks which interface, which VLAN is it configured for. And based on that VLAN, it tags it with that particular VLAN when it is sending out. Clear?
Yes, yes, clear.
Now, with that, I'll ask you one interview question. This is very, very, very commonly asked and frequently asked interview question. Okay. So please remember whatever we discussed about access mode. Okay, access mode and trunk and tagging. Okay. So the question is, we'll discuss the solution or the answer for this question in on Tuesday's class.
Okay.
So switch number 1. Okay, there are two PCs. PC1, PC. PC1, switch to PC2. Okay. 10.0.0.1, 10.0.0.2. Okay. This is access mode VLAN 10, access mode VLAN 10, access mode VLAN 20, access mode VLAN 20. If I do a ping of 10.0.0.2, will the two PCs communicate or not? This is the question.
No, it will not because we have 10. So 10 is there. 10 goes other
Access
side.
mode, access mode 10, and this is also access mode 20.
20. And middle one, what is that? Middle 10, the
This
center
is also
connection.
access mode. Yeah, both. I mean,
Oh,
both the
both are
interfaces are yeah, yeah. Both the interfaces are configured for access mode.
okay. Trunk is not there like we had this
Trunk is
previously.
not there in between these two switches. Trunk is not there.
If it is
These two are
access,
access mode.
then this will send to this, and it will go to the other side. It will go to 20, but 20. Okay,
No problem.
this is
Think about it. This is a very
okay.
commonly asked interview question. Okay. Common and frequently asked. Okay. Even when I gave the interview when I just had 1 year of experience. Okay, they asked me the same interview question, and even after 10 years, I hear people that they ask them this question. That means in the past 10 years, this is the most frequently asked interview question just to check your knowledge on VLAN.
So most of the time they will ask this. Okay.
Every single time, if you say you're good at VLAN, this is the question. So that is why I said, please think whatever we discussed on access mode, trunk mode, and tagging. You will
Tagging.
be able to answer this. All right. So we'll discuss this on Tuesday.
Tuesday.
Monday
Okay.
is Diwali. Monday is Diwali, so there's no class.
Monday will go. Okay. Okay.
Yeah. So Monday is an off. So on Tuesday we'll discuss.
Sure. Thanks, Lakshmi. It was a very nice session. A lot of things got understood.
No problem. Yeah. Thank